semaphore algorithm, it is invented by the scientist Dijkstra. Then in the semaphore algorithm, it uses the variable to see. So in the semaphore, it uses the variable and name of that variable is s. So this semaphore, this s, it is an integer variable and whose value can be accessed and changed only by two operations. So there are two operations or two functions defined in this algorithm. So name of the first operation is the wait operation and name of the second operation is the signal operation. So the other synonyms used for these operations are, that is this wait signal, it is also called as operation P, that is capital P. It is also called as sleep signal or sleep function, or it is also called as down operation. And this signal, the different synonyms for this signal keyword are the keyword, that is the alphabet V, or it is also called as wake up operation, or it is also called as up operation. So this s is any integer variable, it can take any non-negative integer value. So when the, let us consider that number of processes are there which are present in the ready queue and all the processes are waiting for the CPU. So when the processes are waiting for the CPU, means here they want to enter into the critical section for execution. So before entering into the critical section, that process that has to execute the entry code which is written in the semaphore. So when that process, it will execute the entry code successfully, then only that process is able to enter into the critical section. And once the execution of that process will be completed, then for coming out from that critical section, that process has to execute the code which is written for the exit operation. That is, that process, it will execute the exit code, and if that exit code it is executed successfully, then only that process it will come out from that critical section, and then other process that can enter into the critical section by executing the entry code. So in the semaphore, it is compulsory for all the processes, means we are using the multiprocessing environment, number of processes are there in the ready queue, and it is compulsory to all the processes to execute the entry code for entering into the critical section, and for coming out from the critical section, it is compulsory for all the processes to execute the exit code. So there are two types of semaphores, counting semaphore and binary semaphore. So depending on the value of the variable s, this semaphore, it is classified into two types, that is counting semaphore and binary semaphore. So when the semaphore is called as counting semaphore, so the semaphore, it is called as counting semaphore if that variable s, it will take any non-negative integer value. Then that semaphore is called as counting semaphore. And if value of the s, if it is in between 0 and 1, if it will take only two values, then that semaphore is called as binary semaphore. So normally this s, it is nothing but the flag, or it is nothing but the interrupt which is set by your by your operating system. And depending on that value of the s, your process can enter into the critical region or restricted from entering into the critical region. So normally this semaphore algorithm, it can be used to enforce mutual exclusion. Means by using the semaphore here, only one process can enter into the critical section, or only one process is able to use the shared area or shared code which is written for the multiple processes. On the left hand side, it is representing the entry code. On the right hand side, it is representing the exit code which is written for the semaphore. So this entry code, it is also called as wait function, or it is also called as up. And here the exit code, it is also called as signal function, sorry, it is also called as down, and the exit code is also called as signal function, and it is also called as v, wake up or up function. So here this is the normal code which is written in the C language. So here in the wait function, you can observe that initially the value of the variable, that is this value of the variable s, it is passed to the wait function. So whenever this value of the s, it is initialized by the user, and when that value, this s is the global variable here, that is value of the s, it is accessible to the entry code, and it is also accessible to the exit code. And initially that value of the s, it is declared by the user. So when that function is called, when this wait function is called, when the process want to enter into the critical section, then it will call the wait function, and the value of the variable s which is declared by the user, that will get collected into the variable s. Now into this entry code here, we are decrementing the value of the s. So let us consider that initially the value of s is equal to 5, which is declared by the user. So when the process will call this wait function, that value 5, it will get collected into the variable s. And after that, it will execute the statements which are written after this. So now here it will decrement the value of the s by 1. Means here 5 minus 1, which is equal to 4, and then it will execute the if statement, that is if this 4 is less than 0. So if this condition is true, so if this condition is true, then it will execute the else part, that is it will execute the statements which are written after the else part. That is, if 4 is less than 0, so this condition is false, then it will execute the statement which is written after the else. So your process, it will entered into the critical section. That is, that process, it can access the shared area or shared region. But now if this condition is true, so if this condition is true, if that value of s is less than 0, then it will execute the statements which are written after the if, that is before the else part. It will execute the statements which are written before the else, that is that process is suspended. And whenever any process is created by an operating system, your operating system, it creates the process control block for each process, and that process control block, it is used to save or keep the information related to the process. If this value is less than 0, then your operating system or the semaphore algorithm, it will keep this process control block into the suspended list or into the block state, or we can say that into the wait state. So that process, it will entered into the sleep state. Okay. Now once the execution of the process, it will get completed, then before coming out from the critical region, the process has to execute the exit code which is written for this semaphore. So again here it will execute the exit code, and it will increment the value of the semaphore variable by 1. And then it will check if it is less than or equal to 0. If that value is less than or equal to 0, then it will check whether any process is present into the suspended list. That is, in the multi-programming environment, multiple processes are there. So if currently process P1 is executing in the critical region, if it is utilizing the critical section, that time suppose 10 processes are there which are present in the suspended list. Then here it will select one of the process from the ready queue depending on the first come first serve basis, or by using the process scheduling algorithm, and then it will assign the critical region to that particular process. And then this another process, it can enter into the critical section only after executing the entry code which is written for this semaphore. Okay. So now here we will understand this wait code and entry code, that is entry code and exit code, by using the by taking one example. So on the left hand side, I am representing the entry code. So this wait signal, it is representing the entry code. And if the 5 processes are there which are present in the ready queue, and all the processes want to use the shared area or shared region, and all these processes want to enter into the critical section, then before entering into the critical section, each process has to execute the wait code or entry code. So let us consider at first process P1, it arrives in the ready queue. So P1, it arrives in the ready queue, then P1, it will execute the entry code which is written in the semaphore. So let us consider that initially the semaphore value, it is set by the user. So that can be any value. So normally these operating system questions that are asked in the GATE exam, if you will appear for the GATE exam, then in that case this codes, this small code is given for wait and signal operation, and this value of the variable is given, semaphore value is given, and you have to check that which processes are able to enter into the critical section and which process that will be placed into the suspended list. So how this code, it will get executed, that we will see now. So initially this value, let us consider that s is equal to 3. This value is set by the user. So now that value, it will get collected, and your process, it will call this wait function or entry code. So it will call that entry code, and that value 3, it will get collected into the variable s. So this value will get collected into the variable s. Then here value of current value of the variable s or semaphore variable, it is equal to 3. So it will decrement that value, that is in the entry code we are decrementing that value by 1. So we will decrement that value by 1. So 3 minus 1, which is equal to 2. Okay, so that value is decremented by 2. So after that, it will execute the if section. So here it will check if value of the current value of the s variable if it is less than 0. So current value of the variable it is equal to 2. So it will check if 2 is less than 0. So 2 it is not less than 0. This condition is false. So this condition is false. So it will not execute the statements which are written after the if. So it will execute the else part of the if statement. So what is the else part of the if statement? So 2 is less than 0. This condition is false. So that process P1 it can enter into the critical section. Its meaning is that this condition is false. इसका मतलब क्या है कि अभी critical section में no other process is there which is utilizing the CPU or which is utilizing the shared region or shared area. Your critical section is free. So critical section free है मतलब this condition is false. Wait signal का if statement false होगा and then your process it will enter into the critical section. So here I am showing the three sections. So proper understanding. Here I am assuming that you are using multi-processing environment and here multiple regions, multiple processes are there. That is nowadays we are using dual core, quad core or octa core processors. Processors means dual core means multiple processes that can execute on the multiple processor at a time. Or suppose now in a lab, suppose 4 printers are there and 20 PCs are there and 20 PCs are sharing the 4 printers or 3 printers. So that printer it is nothing but the output resource or output device and that is shared by the that output resource it is shared by the multiple processes. So here we will assume that the three printers are there, 3 shared printers are there and that are shared by these 5 processes. So this condition is false. So your process P1 it will enter into the critical section. That is that process P1 it can use the output resource or it is able to use the printer. So currently now your process P1 is present into the critical section. Now let us consider that when the process P1 it was executing, the process P2 it enters into the critical section. So when the process P1 was executing, process P2 it enters into the critical section. Then again for entering, that process P2 it will enter into the ready queue and for entering into the critical section that process P2 it has to execute the wait code or entry code which is written for the semaphore. So again your process P2 it will start from this statement. That is process P2 it will call the wait function or entry code and then now the updated value of the variable s it is equal to 2. So it will call this wait function and then new value of the s that is this 2 value it will get collected into the variable s. So that value 2 it will get collected into the variable s. So now the new value of s is 2. Now when the process it entered into the wait function, that time here it decrement the value of the semaphore variable by 1. So it will decrement the value of semaphore variable by 1. So 2 minus 1 it is equal to 1. And after that it will check the next condition. So here it will check if 1 is less than 0. So again this condition is false. So it will not execute the statements which are written after the if. It will execute the else part. So 1 is less than 0. This condition is false. So it will assign the critical section, that is second printer it is assigned to the process P2. Okay. So process P2 it is entered into the critical section. Now let us consider that when the process P2 was executing, process P3 it enters into the ready queue. And now for entering into the critical region, your process P3 it will execute the wait function or entry code which is written for the semaphore. Consider that the third process is there. That is process P3 it enters into the ready queue and now that process it will call the wait function or entry section. Then here the new modified value of the semaphore variable it is equal to 1. जो previous value था in the previous iteration, that value this process P2 it has modified that value of the s to 1. 2 minus 1 is equal to 1. So current value of the variable it is equal to 1. So now what your process P3 will do now? So now current value of the variable s is equal to 1. So that value 1 it will get collected into the variable s. Now here it will execute the entry section. So now it will decrement the value of s by 1. So current value of s is equal to 1. So new value of the variable s it is equal to 1 minus 1 which is equal to 0. Okay. So current value of the variable is 0. So again it will check the condition, that is if 0 is less than 0. So if this condition is false. If this condition is true, then that process is suspended. But now this condition is false, so it will execute the statement which is written after the else part, and your process, it will enter into the critical section. So suppose 3 printers are there and 5 processes, 5 computers are there, 5 users are there, and all are sharing the printers. So now that 3 printers that are already assigned to the 3 processes. So your critical section is busy now. It is not empty because every slot or every output resource is allocated to one of the process. So this critical section, it is assigned to the process P3. Now, when the process P3 it was executing, the process P4 it enters into the ready queue. So process P4 it enters into the ready queue. For entering into the critical section, then that process it has to execute the entry section or entry code which is written by using the semaphore. So now it will take the updated value of the variable s. So new updated value of the variable s, it is equal to 0. So new value is equal to 0. So that value 0, your process P4, it will call the wait function. So it will call the wait function and it will pass this new value of the s to the variable s. So that value 0, it will get collected into this variable s. So that value will get collected into this variable s, and after that it will execute the next statement. So next statement is again in the waits function. Here we are decrementing the value of s. So here you have to decrement it by 1. So here it will take the new value that is 0. So 0 minus 1 it is equal to minus 1. So modified value of the semaphore variable it is equal to minus 1. Okay. So now it will check the if statement, that is if minus 1 is less than 0. So this condition is true because here critical section is full now. It is not empty. So minus 1 is less than 0. So as this condition is true, so it will execute the statements which are written after the if statement. So it will execute the if part now. So what it will do, now it will put the process control block of the process P4 into the suspended list. So here, if you remember the life cycle diagram of the process or process state diagram, or it is also called as process transition diagram. So in that we have studied different states of the process. So in that case, suppose process is waiting for the input output resources. So here process it is waiting for the printer. So process is waiting for the printer, that is output resource, and your output resource is not free, then process it will get entered into the block state. So similar to that, that process it is entered into the suspended list. That is process control block of P4, it is entered into the suspended list, and that process it is block, or it is now that process it enters into the sleep state because minus 1 less than 0, this condition is true. So here I will represent the suspended state, and in the suspended state here let us consider that P4 it is entered into the suspended queue. So normally this is the queue, that process P4 it is entered into the suspended block or wait queue. You have to remember here, here you can observe that value of the semaphore variable is minus 1. So if value of the semaphore variable is negative, if it is minus 1, its meaning is that one process is present in the suspended state. One process it is present in the block state, wait state, or suspended state. Okay. Now here let us consider that when the process P4 it was executing the entry section, that time process P5 it has entered into the ready queue. Now that process P5 again it will try to enter into the critical section. So your process P5 it will execute the entry section code. So now process P5 it will execute the entry section code. So we'll consider the process P5. So the previous modified value of the variable s by the process P4, it was minus 1. So now the new value of the s is equal to minus 1. So your process P5, it will consider this new modified value, that is minus 1. So new value of s it is equal to minus 1. So it will execute the entry section code. So now entry section code is again, now it will decrement the value of the semaphore variable. So it is minus 1. Value of s dot value it is minus 1 because that value is passed by the process P5 and it is collected into the variable s, and now that is decremented by minus 1. So minus 1 it is equal to minus 2. So again it will check the condition, that is if minus 2 is less than 0. So this condition is true. So this instruction is executed successfully. So it will execute the statement which is written after the if part. So minus 2 is less than 0. So now what it will do, its meaning is that your critical section is full. There is no space present in the critical section. All 3 printers are assigned to the all 3 processes. So now here process P4, it cannot use the critical section. So now what it will do, it will shift the process P5 into the suspended list. It will enter into the block state or it will enter into the sleep state. So here we will show the suspended queue here. that is process after the process P4, process P5, it has entered into the suspended state. So now in the suspended state, two processes are there, P4 and P5, and that are waiting for the critical section. So again, I am telling you that here value of the modified value of the variable s, it is equal to -2. S का जब value -1 था, so meaning of that is meaning of this value, its meaning is that only one process is present in the suspended queue. Now here value of s is equal to -2. So what is the meaning of that? That two processes are there which are present into the suspended state, P4 and P5. Let us consider that now six processes there. P6 अगर यहाँ पे आया तो iteration 5 for P6 will be, यहाँ पे s की value -2 है, तो this value will be -2 -1 मतलब -3. तो s की value -3, इसका मतलब है कि now three processes are there which are present in the suspended state. So जो s की value है आपकी, if it is negative, so from that value only you can find out that how many processes are there in the suspended state or into the wet state. Okay, so now two processes are there into the suspended state. Now here we are considering only five processes. So now let us consider that signal, that is signal or wake up or off function again. Now let us consider that three processes are there which are utilizing the printer or which are utilizing the shared region. Now let us consider that process P1, it has finished its job, it had done its execution, then that process, it is executed completely or successfully, then before coming out from the critical section, means now here it has utilized that printer resource. So now for coming out from the critical section, it has to execute the exit code of the semaphore, then only that process it can come out from the critical section. So process P1, it is completed its execution, so that process P1 now will execute the exit code. Okay, exit code of the semaphore. So now see, this is the exit code. So now we know that there are two processes which are present into the suspended state, that is process P4 and P5, and process P1, it will come out from the critical section and it will execute this exit code which is written on the right hand side. So अभी मैं right hand side का exit code consider कर रही हूँ and I am writing the details of that on the left hand side. तो यहाँ पे on the right hand side you can observe that this is the exit code. So now process P1, it will execute the exit code. So P1, it will execute the exit code. Now here s is the global variable. So the previous modified value of the semaphore variable s, it was -2. Okay, that was -2. So it will consider the previous value of s, that was -2. So your process P1, it will call the signal function, and this new modified value of s -2, it will get collected into the variable s. Now here you can see the difference in between the wait function and the signal function, or also we can call it as down function or up function. That is, in the wait function we were incrementing the value of the semaphore variable, we were decrementing the value of the semaphore variable, whereas in the signal function we are incrementing the value of the semaphore variable. ये difference है दोनों इसमें. जो आपका वेट फंक्शन था वहां पे हम -1 कर रहे थे, और जो हमारा सिग्नल फंक्शन है वहां पे हम इंक्रीमेंट कर रहे हैं, and that value is incremented by 1. So this is the difference there. Okay, so initial value, now the new value of the s is -2. So now it will increment that value of s by 1. So -2 plus 1, it is equal to -1. Okay, so it is -1. So -1, it is less than or equal to 0. So this value is less than or equal to 0. So it will select the process P4 from the suspended list. So it will select the process P4 from the suspended list. So it will wake up that process. It will wake up that process and then it will add that P4 into the ready queue. अभी P4 कहाँ पे add होगा आपका? ready queue में add होगा. Okay, because process P1, it has executed the exit code, it has decremented the value of the semaphore variable. अभी ये condition आपका true है, इसके वजह से it will select the process. Here you can see this code which is written on the right hand side. So it will select the process from the suspended list. Suspended list में आपके कौन से process थी? Process P4 था और P5 था. अभी ये condition true है because of the P1. So P4, it is cancelled from the suspended state and it will get added into the ready queue. देखो यहाँ पे you can see this 3. So initially P1, it has completed its execution. So now this P1, it is deleted from the critical section, but before coming out from the critical section, your process P1, it will execute this signal function. तो उसने वो signal function execute किया है, that is up function execute किया है, and it is telling the operating system that I have completed my job and I want to come out from the critical section. So that's why it is executing this part. So यहाँ पे उसने value increment किया or after that it is checking this condition and it is selecting the process P4 from the suspended list, and that process P4 it is added into the ready queue. Okay, now let us consider that आपका so now we will consider the P2. Yes, यहाँ पे अभी suspended state में only process P5 is there, P4 is not there. So only P5 is there. You do not write down this. Now let us consider the process P2. So now critical section में P1 it is already come out from the critical section by executing the exit code. Now let us consider that process P2 it has also completed its job. Now it want to come out from the critical section, then process P2 it has to execute the exit code which is written for the semaphore. So your process P2 it will execute this exit code. So the previous value of S it was -1. जो previous value था आपका S का that was -1. Okay, so it will carry forward that value -1 and it will this process P2 it will call the semaphore function, and that -1 that value will get collected into the variable S, and now it will execute the next statement. So here we are incrementing that. So -1 + 1 it is equal to 0. So यहाँ पे 0 is less than or equal to 0. This condition is true. So what it will do? It will select this process P5 from the suspended state. यहाँ पे P4 नहीं है. It is already added into the ready queue. So it will select the next process. It will check whether any process is present into the suspended queue. So it will select that process P5 from the suspended state, and after that it will wake up that process and it will add that process into the ready queue. So in the ready queue now two processes are there, P4 and P5. Okay, after that now now let us consider that next process which is present in the critical section, that is process P3. So P3 has also completed its execution, so it will execute the exit code. So now it will execute the exit code. So in previous value of S, modified value of S, it was 0. So now what this process P3 will do? It will increment the value of S by 1. So 0 plus 1 abhi 1 ho gaya. So it will check 1 is less than or equal to 0. So this condition is false here. So here no process is present in the suspended list. जो दो processes थी आपकी suspended list में P4 और P5 that are already added into the ready queue. तो अभी suspended list में आपका कोई भी process नहीं है. So now your process P3 it will come out from the critical section. Okay, so now let us consider the process P4. So now we will check the iteration for the process P4. जो अभी new modified value था आपका semaphore variable का that was 1. So now process P4 it is present in the ready queue. दो process है आपके ready queue में P4 and P5. Now P4 it want to come into the critical section, so it has to execute the entry code or wait code. So the previous value of S it was 1. So अभी entry code में हम क्या कर रहे हैं, semaphore का value 1 से decrement कर रहे हैं. तो अभी S का value it will decrement by 1. So 1 minus 1 is equal to 0. So this value is 0. So it will check 0 is less than or equal to 0. So this condition is false. So it will execute the else part and it will enter the process P4 into the critical section. Okay. अभी let us consider the iteration 5 means next process P5. So अभी जो previous value था आपका S का that was 0. So process P5 इसका value अभी 0 है. Process P5 it will execute the wait function और entry code. So जो previous value था आपका S का वो 0 था. So now it will decrement that value by 1. So 0 minus 1 का value आपका -1 हो गया. So here it will check -1 is less than 0. तो -1 लेस देन 0 कंडीशन तो आपका ट्रू हो गया. लेकिन यहाँ पे आप ऑब्जर्व कर सकते हो कि वहां पे तो 3 प्रिंटर्स थे, अभी तीनों प्रिंटर्स खाली है. ओनली वन प्रोसेस दैट इज प्रोसेस P4 it is utilizing the first printer and other two printers are free, other two shared regions are free. So here but ये कंडीशन अभी आपका ट्रू हो गया है, -1 लेस देन 0. So though the shared region or critical region is free, here this condition is true. So because of this process P5 it is again added into the suspended list. So that process is again added into the suspended list and it will not execute the process, it will not assign the critical region to process P5. So now what are the advantages of the semaphore? That they do not allow more than one process to enter into the critical section. अभी हमने देखा है कि mutual exclusion is achieved because of the semaphore and only one process is able to enter into the critical section. So this is the main advantage. So mutual exclusion is achieved here, and due to busy waiting in the semaphore, the processes are only allowed to enter the critical section after satisfying the certain condition. अगर condition आपका true हो रहा है, then only that process is entered into the critical section. So disadvantages of the semaphore. So So यहाँ पे what can be the disadvantage of the semaphore? So we had learned the priority scheduling algorithm. So priority scheduling means normally the user defined processes are the lower priority process, and the kernel or operating system processes are the higher priority processes. So if the higher priority process that are entered into the ready queue, then the current process which is executing the CPU, if it is lower priority process, then that will get preempted, and the CPU or critical section it is assigned to the higher priority process. But if you are using semaphore for scheduling the job, then it is not possible for the higher priority process to preempt the process which is running or which is utilizing the critical section, because that process it can be preempted only when it will finish its job and it will execute the critical section. Okay, and here to avoid the deadlock, see, this is the thing: to avoid the deadlock, the wait and signal operations that have to be executed in the correct order.